Welcome to part 2 of the tour of the solar system. Previously, we looked at the inner solar system and what lies there. This time we'll be looking at the outer solar system, which includes the planets Jupiter, Saturn, Uranus, and Neptune. First, we will be taking a close look at what separates the outer solar system from the inner solar system, the asteroid belt. Located between the planets Mars and Jupiter, the asteroid belt is home to a collection of dust and rocks left over from the formation of the solar system 4.6 billion years ago. The word asteroid is derived from Greek and has the meaning star-like, as when a man named William Herschel was observing them in 1802, he had no idea what he was looking at. Herschel is often given credit as coming up with the term asteroid. However, it is believed the word was actually coined by Greek scholar Charles Burney, who came up with the word while collaborating with Herschel on a poem about the cosmos. Currently, it is estimated that there are 1.28 million asteroids in the solar system, of which most of these asteroids are located between Mars and Jupiter. They range in size from 530 kilometers in diameter, which is the size of the asteroid Vesta, the largest known asteroid in the solar system, to just a few meters across. Asteroids can be classified in three broad categories relating to their composition. The first classification is C-type asteroids, the C standing for chondrite. These are the most common form of asteroid and likely contain clay and silicate rocks. They also have a dark outer appearance and are among the oldest objects in the solar system. The second class of asteroid is S-type, where S stands for stony. These asteroids are made up of mostly silicate material, as well as nickel and iron. The final class of asteroid is M-type, where M stands for metallic. These compose primarily of nickel and iron. The difference in composition of these asteroids is related to how far from the Sun they were formed. Some asteroids would have encountered high temperatures after their formation and partially melted, causing the iron to sink to the centre and forcing volcanic lava to the surface. The formation of Jupiter disrupted the formation of new planets in the asteroid belt region by causing the scattering of asteroids. And despite containing millions of objects, due to the vastness of space, the density of the asteroids within the belt is so low that spacecraft can pass through the region with next to no risk of collision. The fifth planet from the Sun, and the largest in the solar system, Jupiter is the second brightest planet in the night sky, second only to Venus. Jupiter perhaps has the grandest origins for its name in the solar system, as it is named for the Romans' most powerful god, the god of the sky and the king of the gods. This planet is also the first one we encounter on this tour, which is primarily made up of gases as opposed to solid materials such as metal and rock. Unlike previous planets, Jupiter has a vast network of natural satellites in orbit. As of 2023, it has at least 80 moons that have been discovered, which is a significant increase from the record holder of the inner solar system, Mars, which only has 2 moons. The first 4 moons discovered around Jupiter are known as the Galilean moons, and are named Io, Europa, Ganymede, and Callisto, and they were discovered by Galileo Galilei. His discovery of objects which orbited around another object and not perceivably around the Earth had profound impacts for religion and society as a whole in the 1600s. Io is the second smallest and the innermost of the 4 Galilean moons. It has over 400 active volcanoes on its surface, making it the most volcanically active body within the solar system. The moon also has a very thin atmosphere that is made up of mostly sulfur dioxide emitted from its volcanoes. Europa is the smallest and the second innermost of the Galilean moons. It is nearly the same size as Earth's moon and is tidally locked to Jupiter in its orbit, and so spins faster on its axes than it orbits. And due to Europa being water-rich, with a warm interior, it is hypothesized that it could be hospitable to life. Ganymede holds the title of being both Jupiter's largest moon, as well as being the largest moon within the solar system. It is so big, in fact, it is larger than the planet Mercury, and had it not been in orbit of Jupiter, would likely be considered a planet. Much like Europa, it is suspected Ganymede has a subsurface ocean in addition to having a liquid iron and nickel core, making the moon the only one in the solar system to have a substantial magnetosphere. Callisto is the second largest moon in orbit of Jupiter and is almost the size of Mercury. It is also the most distant of the 4 Galilean moons from Jupiter. The most prominent feature on the surface of Callisto is a multi-ringed impact basin called Valhalla. It stretches across more than 1,800 kilometers and was created during an impact around 2 billion to 4 billion years ago. It is also the most heavily cratered body in the solar system, and its surface is layered, with a rigid outer surface and an interior ocean likely made of water, along with salts or possibly ammonia. Jupiter began its formation around 4.5 billion years ago, when gravity attracted gas and dust to a singular point, which eventually became what we know as the planet Jupiter. The planet acquired most of the leftover mass from the formation of the Sun, and so has twice the combined mass of all the other planets in the solar system. Jupiter has the same material as many other stars, however the gas giant did not grow large enough to undergo nuclear fusion. Jupiter actually has a very thin ring system, as do Neptune and Uranus, and the Great Red Spot is a massive storm on Jupiter which has been raging for over 350 years. The storm is so large that 3 Earths could fit inside it. Jupiter also has the shortest day of any planet within the solar system, with a full rotation on its axis being completed every 9 hours and 55 minutes. It has an orbital period of 11.8 years. The next celestial object we will be taking a look at is Saturn, the 6th planet from the Sun. The Romans once again lent one of their gods to the naming of this planet, and is named after Saturn, the god of plenty, agriculture and time. Saturn, much like Jupiter, is made up of gases instead of rock and metal, and is host to one of the most beautiful sights to behold through a back garden telescope, the rings of Saturn. It is also host to over 124 moons. Since Saturn has such a large pool of moons to choose from, it may come as no surprise to learn that some of these moons have gathered great interest from the likes of NASA and the ESA. Such moons include Titan and Enceladus. Titan is Saturn's largest moon, and the second largest moon in the solar system, as well as perhaps being the most interesting natural satellite within our planetary neighbourhood. It is the only moon to be host to a truly substantial atmosphere, and it has an assortment of liquid flowing rivers, lakes, and seas of methane and ethane on its surface. Its atmosphere is mainly composed of nitrogen, however its surface pressure is around 50% greater than on Earth. Titan has a thick crust of water ice, however beneath is an ocean primarily composed of liquid water, the very same stuff we find when we go to the beach. It is suspected due to this that beneath the crust could be life as we know it, or life as we are yet to know it. Enceladus is another moon of Saturn's that is host to a liquid water ocean beneath its surface. However, this moon shoots the liquid from beneath its surface out into space, where spacecraft are able to take samples of the ejected material. It has been determined that Enceladus has most of the chemical ingredients for the creation of life as we know it. When the Voyager spacecraft passed by Saturn and its moons, pictures from these craft indicated that despite the small size of Enceladus, it is incredibly smooth in some places and bright white all over. It is the most reflective body in the solar system, and because of this, it has a surface temperature of 72 Kelvin. The main attraction of the planet Saturn is its astonishing ring system. This huge and complex structure is so large that from edge to edge, it would be unable to fit in between the Earth and the Moon. There are 7 main rings, A through E, and are listed in the order in which they were discovered. However, from the planets outward, they are listed as D, C, B, A, F, G, and E. The main rings of Saturn are the A, B, and C rings. The outermost of these is the A ring, which is the most easily visible from back garden telescopes. There is a region of space known as the Cassini division, and it separates the A ring from the B ring. The F ring is located just outside the A ring, and is extremely narrow. It is accompanied by 2 very small moons, Pandora and Prometheus. Past the F ring is the much fainter G and E rings. The diffuse E ring expands from the moon Mimas to Titan, which is about 1 million kilometers. Finally, the D ring is the closest ring to Saturn and is extremely faint. Saturn formed around 4.5 billion years ago along with the rest of the solar system, when, like Jupiter, gas and dust was attracted to one point and resulted in the formation of this gas giant. And then, approximately 4 billion years ago, Saturn entered into its current orbit and position within the outer solar system. It is also made up of hydrogen and helium, once again much like Jupiter and the Sun. Saturn has the second shortest day in the solar system, behind Jupiter, with a rotational period of 10.7 hours. Its axis is tilted by 26.7 degrees with respect to its orbits around the Sun, which is similar to that of Earth's 23.5 degree tilt, and so Saturn also experiences seasons. We now approach the 7th outermost planet in the solar system, Uranus. This planet perhaps has one of the strangest origins for its name. The name we know it as today is named for the Greek god of the sky. However, when it was directly observed by William Herschel in 1781, he named it after the monarch of Great Britain, King George III, and so the planet was named Georgium Sidus. For better or for worse for patriotic Britons, around 70 years after the planet's observation, it was renamed to Uranus, the name of which was suggested by Johann Bode many years prior. Bode assisted in getting Uranus accepted as a planet because of his own observations 2 years after Herschel's observations. Unlike Jupiter and Saturn, Uranus has substantially fewer moons, hosting 27 natural satellites, which is still more than any in the inner solar system. The moons of Uranus are not named for Greek or Roman gods, like most of the other moons in the solar system. Instead, they are named after characters from the works of William Shakespeare and Alexander Pope. Uranus's inner moons appear to be approximately half water ice and half rock. However, the composition of the outer moons remains unknown, but are likely captured asteroids. Like all the other planets, Uranus formed 4.5 billion years ago and is one of the 2 ice giants in our solar system. 80% of the planet's mass is made up of a hot, dense fluid of icy materials, water, methane, and ammonia, which is located above a small rocky core. Uranus gets its blue-green colour from the methane gas in its atmosphere. Sunlight passes through the atmosphere and is reflected back by Uranus's cloud tops. The methane absorbs the red portion of the sunlight and so leaves the blue-green colour. As mentioned previously when taking a look at Jupiter, Uranus also has rings surrounding it, 2 sets in fact. The inner rings, of which there are 9, consist of narrow and dark grey rings, and there are 2 outer rings. The 8th and final main planet on this tour is the planet Neptune. The planet was discovered in 1846 by a German astronomer named Johann Gottfried Galle, based on the predictions of French astronomer Urbain Le Verrier. There was some back and forth for a short time between various astronomers and institutions about what this planet should be called, But on December 29th of 1846, a German-Russian astronomer called Friedrich Georg Wilhelm von Struve supported the name Neptune, and so the international community swiftly adopted this name. Neptune is the Roman god of the sea and is akin to Poseidon in Greek mythology. Neptune has 14 known moons, its largest of which is Triton, and it was in fact discovered merely 17 days after the discovery of the planet itself. Its various moons are named after lesser Greek gods of the sea, due to the naming of Neptune itself. Triton is the only large moon within the solar system that orbits its host planet in the opposite direction to the planet's rotation, which is known as retrograde. Once again, Neptune was formed 4.5 billion years ago and is made up of the same material as Uranus, a dense fluid-like icy assortment of materials made up of water, methane and ammonia. Of all the gas giants in our solar system, Neptune is the densest of them all. Surrounding the planet is a faint ring system which consists of 5 main rings and 4 prominent ring arcs that have been discovered so far. From the innermost ring to the outermost, the rings are named Gal, Leverrier, LaSalle, Arago and Adams. The final region of space we will be taking a look at on this tour is called the Kuiper Belt. The name comes from Gerard Kuiper, who published a paper in 1951 that speculated about objects beyond what was, at the time, the planet Pluto. The region is also sometimes referred to as the Trans-Neptunian region. The belt encompasses a huge volume within the solar system. Within the Kuiper Belt lies many objects, dust, asteroids, comets and dwarf planets. Objects in the belt tend to be extremely influenced by the planets Neptune and Jupiter. These objects that are under the influence of these planets tend to be on a journey that will either see them flung out of the solar system into interstellar space, or will be slammed into the Sun or one of the inner planets. This process takes millions upon millions of years to take place, however. Undoubtedly the most famous Kuiper Belt object is the dwarf planet Pluto. Discovered in 1930, it was the first object to be discovered within the Kuiper Belt. After further observations in that region of space, however, the then planet was reclassified to a dwarf planet in 2006 by a committee in Prague, which redefined the parameters of what it means to be a planet. Pluto met 2 of the 3 requirements. The one it did not meet was the requirement to clear its surrounding neighbourhood of other large objects and the obtaining of gravitational dominance in the region. Pluto has 5 known moons, Charon of which is its biggest. It is believed that the objects within the Kuiper Belt are remnants left over from the formation of the solar system. Much like the asteroid belt, it is a region of space where a planet may have formed had Neptune not been there. However, due to the planet's gravity causing havoc in the region, the small objects that would have come together to form a planet were simply unable to do so. The Kuiper Belt is donut-shaped and resides around 30 AU from the Sun, and the main region of the belt ends approximately 50 AU from the Sun. The second region, known as the scattered disk, continues outward to around 1000 AU, and even still, there are some objects on orbital paths that go out past this point. This concludes the tour of the solar system. On this journey we have seen many comets, asteroids, planets and sites such as the stunning rings of Saturn and the great red spot of Jupiter. There is so much within our solar system in our tiny place in this galaxy. It is mind-boggling to think and conceive about what else could be out there, in the cosmos just waiting to be discovered.